Next chapter, fractions. Fractions are simply a part of a whole. If you take a whole item and divide it into 5 equal parts, we would say that this part is 1 out of the 5, so its size is 1 over 5 or a fifth. These two are 2/5 and so on. So every 1 month is 1 over 12 of a year because there are 12 months in a year. If you score 10% in an exam, it simply means you scored 10 marks out of the possible 100, and so the fraction is 10 over 100. In a fraction, the digit above is the numerator and the one below is the denominator. In a fraction, the line can be horizontal or slightly slant, but it means the same thing. If the numerator of a fraction is smaller than the denominator, the fraction is called a proper one. For example, 2 over 5, 1 over 3, 3 over 7, 5 over 7, and so on. Proper fractions are smaller than 1. If on the other hand the numerator is larger than the denominator, the fraction is called an improper one. For example, 2 over 3, 5 over 4, 9 over 2, and so on. An improper fraction is larger than 1. An improper fraction can be expressed as a mixed fraction, having a whole number and a proper fraction. For instance, 3 over 2 can be written as 1 and 1 over 2. 9 over 2 can be written as 4 and 1 over 2. 13 over 5 can be written as 2 and 3 over 5. Next, simplification of fractions. A fraction should be written in the simplest way possible. So the numerator and denominator should be simplified as much as possible. For instance, 10 over 100 can be simplified by dividing both the numerator and the denominator by 10. So we have 1 over 10. Equally, 6 over 15 can be simplified into 2 over 5 by dividing both numerator and denominator by 3. Simplification does not change the fraction, it simply makes it easier to work with small numbers. In other words, when you multiply or divide the numerator and denominator by the same factor, the fraction does not change its value. That is to say, 1 over 2 is equal to 2 over 4, which is equal to 3 over 6, and it's equal to 50 over 100. These are called equivalent fractions. Next, comparing fractions. Now arrange these fractions from the smallest to the largest: 2 over 5, 1 over 3, 4 over 5, and 2 over 9. To be able to do that, we simply multiply the fractions with the common factor, preferably the LCM of the denominators. So in our case, the LCM of 5, 3, and 9 is 45. 2 over 5 times 45 is 18. 1 over 3 times 45 is 15. 4 over 5 times 45 is 36. 2 over 9 times 45 is 10. So the order is 2 over 9, 1 over 3, 2 over 5, and 4 over 5. Operations on fractions, addition and subtraction. When we add or subtract fractions with equal denominators, we simply add the numerators. So 2 over 5 plus 4 over 5, we retain the denominator 5, then 2 plus 4, which gives us 6. As a mixed fraction, that is 1 and 1 over 5. 4 over 9 minus 3 over 9, we retain the denominator 9, and then we have 4 minus 3. and that should give us 1 over 9. If the denominators are different, we work with their LCM. For instance, 2 over 3 plus 1 over 4. The LCM of 3 and 4 is 12. So we write 12 as the denominator. 12 divided by 3 is 4. 4 times 2 is 8. 12 divided by 4 is 3. 3 times 1 is 3. That gives us 11 over 12. 9 over 3 minus 9 over 5. LCM of 3 and 5 is 15. 15 divided by 3 is 5, times 9 is 45. 15 divided by 5 is 3, times minus 9 is minus 27. 45 minus 27 is 18 over 15. We can cancel that by 3 and we have 6 over 5, which as a mixed fraction is 1 and 1 over 5. When working with mixed fractions, it's safer to first convert them into improper fractions. 2 and 2 over 3 plus 4 and 1 over 5. Convert them first. 2 and 2 over 3 is equal to 8 over 3 plus 4 and 1 over 5 is equal to 21 over 5. LCM of 3 and 5 is 15. 15 divided by 3 is 5 times 8 is 40 plus 15 divided by 5 is 3 times 21 is 63. 40 plus 63 is 103 over 15. As a mixed fraction, that is 6 and 13 over 15. Notice that whole numbers can be written as fractions with their denominator being 1. For instance, 3 is the same as 3 over 1. This makes the operations easy. For example, 3 over 5 plus 2 over 3 plus 2. We make 2 a fraction so that we have 2 over 1, and then we proceed as usual. 3 over 5 plus 2 over 3 plus 2 over 1. LCM of 3, 5 and 1 is 15. 15 divided by 5 is 3 times 3 is 9. 15 divided by 3 is 5 times 2 is 10. 15 divided by 1 is 15 times 2 is 30. So we have 49 over 15, which is equal to 3 and 4 over 15. Multiplying fractions. When we multiply a fraction with another, we multiply the numerators and denominators separately. So 2 over 5 times 3 over 2. We shall have 2 times 3, the numerators, over 5 times 2, the denominators, and we have 6 over 10. Simplified, that is 3 over 5. For mixed fractions, we first convert them into improper fractions. 1 and 4 over 5 times 2 and 1 over 3. We have 9 over 5 times 7 over 3. That gives us 9 times 7 over 5 times 3, which gives us 63 over 15. That gives us 4 and 3 over 15. We can simplify the proper fraction and we have 4 and 1 over 5. When multiplying a fraction with a whole number, we just make the whole number a fraction with a denominator of 1. So 3 times 4 over 9. We make 3 a fraction 3 over 1. So 3 over 1 times 4 over 9. Multiply the numerators. 3 times 4 over 1 times 9. So we have 12 over 9, which simplified is 4 over 3 as a mixed fraction, that is 1 and 1 over 3. Sometimes you might have seen people cancel out the denominator with the whole number. Trust me, it doesn't make any difference and the answer is the same. So 4 over 9 times 3, we can cancel 3 and 9. 3 goes into 3 once, into 9 3 times. So you have 4 over 3 times 1, which is equal to 4 over 3. Same answer. Or 3 over 5 times 5 over 6. Looking at this, 3 and 6 can cancel each other. By 3 1, by 3 2. 5 can cancel out, so we end up with 1 over 2. You could also have followed the long method. 3 over 5 times 5 over 6, we multiply 3 times 5 over 5 times 6. We get 15 over 30. And if we simplify that, we'll end up with 1 over 2. But it is not always that the digits will cancel out and you will be forced to follow the long method. For example, 3 over 7 times 1 over 2, no digits can cancel out. Notice that when off is used in a question, it means multiplication. So 2 over 3 of 9 simply means 2 over 3 times 9. And now division. Before we do division, consider the fraction 2 over 3. If you reverse the digits to have 3 over 2, we get what we call a reciprocal. Both these fractions are a reciprocal of each other. When a number is multiplied by its reciprocal, the answer is 1. So 2 over 3 times 3 over 2 is equal to 1. When we divide a fraction with another, we take the reciprocal of the divisor and change the division sign into a multiplication one. So 5 over 4 divided by 1 over 4. The divisor is 1 over 4. Its reciprocal is 4 over 1. So we have 5 over 4 times 4 over 1. 5 times 4 is 20. 4 times 1 is 4. That gives us 20 over 4, which is equal to 5. Or you could have taken the shortcut and cancelled out 4. Notice we are changing the divisor and not the dividend. 3 over 8 divided by 2. Make 2 a fraction, that's 2 over 1. Its reciprocal is 1 over 2. So 3 over 8 times 1 over 2 gives us 3 over 16. Six 1 over 2 divided by 3 and 2 over 3. We change them first into improper fractions. 13 over 2 divided by 11 over 3. Reciprocal of 11 over 3 is 3 over 11. So 13 over 2 times 3 over 11 will give us 39 over 22. Next, combined operations. Now the order BODMAS is used in working combined operations. For example, 1 over 3 of 2 into 1 over 3 minus 2 over 5 divided by 2, close the bracket, plus 5. We start with the bracket, and again inside the bracket we shall start with division. So we shall have minus 2 over 5 divided by 2. That becomes minus 2 over 5 times 1 over 2, which gives us minus 1 over 5. Whether you put the negative sign in front of 1 or 5 or just in front of the entire fraction doesn't make any difference. We are not done with what is inside the bracket, so we shall move to subtraction. 1 over 3 minus 1 over 5 gives us 2 over 15. So now we have 1 over 3 of 2 times 2 over 15 plus 1 over 5. Now we go to off, which is simply multiplication. 1 over 3 times 2 over 1 is equal to 2 over 3. Then we multiply this by 2 over 15. So 2 over 3 times 2 over 15, there's nothing to cancel and we get 4 over 45. We add this to 1 over 5. So 4 over 45 plus 1 over 5. LCM of 45 and 5 is 45. 45 into 45 once times 4 is 4. 45 divided by 5 is 9 times 1 is 9. 4 plus 9 is 13 over 45.
The way we teach it in university and in high school as well, and colleges, is if you fall behind, you're in desperate trouble. That if you miss a class or miss an idea or don't do your homework, you go to the next class and the teacher assumes you know it, but it's like Greek to you. And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor.